stomach is gonna growl.
Okay. I believe this is where we left off. So, you probably talked about this too. How many of you guys have taken AP Psych? Oh, great. I bet you've talked about this in AP Psych.
Yeah.
So, when we're doing an experiment, we've talked about what a treatment is, and that's like what's actually being like applied to our experimental units. What we're trying to like test. So if I was trying to test like the effects of like a drug on somebody, the actual treatment is the drug. We're trying to measure like the effects of that. So a treatment group is just the group that receives the treatment, and the control group, we often assign a group to receive like no treatment, so that we have something to compare our results to. Okay, so the treatment group is the group that receives treatment in an experiment. Obviously, pretty straightforward. Call that their treatment group. And then our control group is the group that either receives no treatment or receives something called a placebo. Or no treatment. In an experiment. Okay, does anyone know what a placebo is?
A sugar pill.
That is an example.
It's
That's honestly what I think of when I think of placebo. It's like a sugar pill. Yeah, a fake thing that you don't know if you're getting the actual treatment or not, like a sugar pill. Yep.
So like they think bargaining. Yeah. So
Yeah, that's the placebo effect. That's what we're gonna talk about next. So the only other thing I want you to put under control is these are like necessary to have in an experiment because we use them to compare to the treatment, or they're used to provide like data, baseline data. For comparison. Getting this written down?
Yeah, Austin.
Yeah.
Oh, okay. Alright. So on the next page, you guys just told me what this is, the placebo, and then what you're talking about, the placebo effect. So placebo in definition, an inactive treatment that has no real effect on the explanatory variable. That's what placebo is. So the placebo effect is when you think you're getting it and you act differently because you believe that you did get this pain reliever pill. So you're like, oh my gosh, I feel so great, I have no more pain, when really it was just a sugar pill, something like that. All right, so, and that's probably what you talked about in psych. Phenomenon where some people experience a benefit after receiving a placebo treatment simply because, bless you. I think I don't like about this stat stuff. It's a lot of definitions. Okay. Because a person expects it will be helpful. You can write that in your own words too if you want, but bless you.
Okay, that's all good.
Example, sugar pill.
It sounded like Newsy sneeze.
Well, normally
Miss
I
Evans, you like scared Miss Evans.
She was like, well, someone woke up. Well, normally I hold him in because I'm like scared, but I just.
It's
Let it out.
Sometimes you just gotta let her rip.
Yeah.
let him out.
Okay. Have you talked about like blinding and double blinding?
Yes.
Yeah. Okay, great. So we're talking about next. So blinding is when subjects and or experiments who are involved do not know if they received the treatment or placebo. So both the subjects and the experimenters I should say. Who are involved do not know if they received the treatment or placebo. Okay, so basically I have like two possible types of blinding. We can do a single blind or a double blind. So a single, the difference is a single blind is when the subjects don't know, but the experimenters do know who has the real treatment, who has a placebo. And then a double blind is when both the experimenters and the people doing the experiment don't know. Okay, hence the word double blind. So single, subjects do not know. If they have received a treatment or placebo. But experimenters do. So single blind, only the subjects, the people taking it, are the blind ones. They don't know if they've received treatment or placebo. Double blind is when neither the subject or the experimenters know which people got the treatment, which got the placebo. Okay. So neither subject or experimenters know whether the subjects are, sorry, I know this is wordy, receiving the treatment or placebo. Okay. The last thing I want to fill out is kind of like these 4 key principles of an experiment. So this is what I kind of like described yesterday when we were designing an experiment. And I said, we're going to kind of like go over these like step-by-steps of what it kind of takes to make an experiment. This is not like laid out, I guess, that way. It's just 4 key principles of what we like need in order to conduct an experiment. So we need some type of comparison. So sometimes you could have 2 or more treatments. So remember, technically a treatment could be like that you're not receiving whatever the treatment is. So you can't just do an experiment and you're like, oh, I'm going to give everybody this same sugar pill or something. That wouldn't be an experiment. You need 2 or more treatments. You need something to like compare it to. And that kind of goes hand in hand with like the control group. So for the control, you want to keep all other variables besides the treatments constant. Random assignment, that's kind of when we're like designating our sample groups. We want to try to do it randomly. Okay. Replication just means that this is like a well-designed experiment, we'll be able to repeat it under like similar conditions and kind of like get similar results. So I just put repetition of an experiment under the same or similar conditions. Okay. That's all we're going to do for notes today. 15 minutes will be enough for that. Tomorrow we'll talk about like randomization, but today I have a little placebo kind of activity. Oh yeah, try to go. It's called Would You Fall for That?
So I'm in a spaceship.
Oh wait, no, it is Wednesday. Yeah.
No way.
Oh. And I can do that. Well, actually, I do.
Yeah, I didn't know that actually because Mrs. Scott used to do that. Pissing me off.
Hey, language.
Okay, this starts with a short video. So I'm gonna play it for you.
Never do that again.
Oh, no.
Okay, sorry. Hold on.
Bloated. Goozy, remember when you were so bloated on the kayak or the canoeing trip?
Stop.
She'd go to the
So
bathroom.
bad.
She'd go to the bathroom so bad. Every time I like think I'm bloated because I go to the bathroom so bad, I know it can't be worse. I know it can't be worse.
No, I literally peed in the
Yeah.
field.
That was
Mia!
I didn't even know you were in there.
Yeah.
Okay.
That was literally was the highlight of my life.
No, I was literally like out to
Not joking, she was too.
That's how small of a bladder I have. Like I have to pee like every 20 minutes if I drink water.
Okay, ready?
Yes.
This is for
I
you.
really needed to lose some weight. I didn't want to have a shortened lifespan.
Is this
an
it?
ad?
It's an ad.
This was at the 20% rolling vodka cheer on, she would cheer me on.
It's showing
Same meals, or choose your own, including premium meals and restaurant
ads.
Yeah, but I'm learning about his weight loss.
Go online or
Is that a fashion? Yeah, that's it.
No,
Yeah.
it's not. He
You
lost
just need
weight
to
through
lose
nutrition.
just like
I didn't say he did. I was making the point that he has.
Rather eye-opening look at human
It's beyond.
behavior as the social experiment continues on this network. ABC's Nick Watt, the host of a great new show, Would You Fall for That, joins us now from Los Angeles. And Nick, tonight you are putting the placebo effect we hear so much about to the test.
That's right, Josh. I mean, you know that we're all about science on this show. Well, not quite. It's a lot of fun as well. Tonight, the placebo effect. If you think something's going to make you feel better than it might, and it's summertime, so for this one, we headed to the beach. Set up a food full of boardwalks and Jersey sweltering hot day. We had t-shirts and toasters, and our very own links.
And then I have a question about that.
Okay, that's like 10 seconds ago. Get over
Always nothing wrong. So if you believe a pill will make you better, then it just might. If you believe an energy drink will make you stronger, it just might. Even if it's just club soda.
I did.
Our minds make. So all we did was tear the labels off club soda bottles to stick on arrows. Would you fall? Would you actually feel strong after a few gulps? It will be amazing.
God dang.
Energy challenge. We're promoting a new drink, and it shows unlimited energy. Just want to step up and take it. It's totally free.
Austin definitely would.
First up, we invite our passers-by to test their strength. Swing the mallet.
Austin would do that. If it was Austin.
7-7, that's respectable. It's not stellar. So Shearer's going to give you some whip right now, and we will increase your whip for this. Whip, 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 whip. So, shoves the whip, and I tell him highly convincing nonsense. That's it. It was discovered by Philip Monroe, who won the Tour de France in 1998. Then, we get him to shake his thing, get the whip pumping through those veins.
Punch all those distractions out of your life. Don't push me. Sorry, punch everything else out.
A nice striker sees just how much the whip has made. Will he get a better score? Stand back, boys. Keith is on fire. Yeah!
Oh, wow.
Just like that, Keith has become a strong man. If you're wondering if we rigged that high striker, the answer is absolutely not. It's the placebo effect network, and Keith felt it. And also tonight, I think one of the most terrifying things I've ever tried to do, I tried to marry a total stranger, someone we put off the street. I tried to marry that person to one of our co-hosts. The results, shocking, astonishing, unbelievable.
A rather eye-opening look at human behavior as
Okay. So. Okay. So there's the video that I go with this. First question. Why do you think the people in the video got stronger?
They didn't get stronger.
You're right, they didn't. Why do you
It's all mental.
Yeah.
Exactly. They thought the drink would make them stronger. So maybe they tried harder. They believed they were stronger. Okay, that, my friends, is a placebo effect at its finest.
Miss Hendricks,
Yes.
is this our classroom?
Not yet. Do you want to print it out?
Yeah, if that's alright.
Yep, I can post it really quick.
Okay.
Okay, you guys ready for this next one? Quick while I get that posted.
in a spaceship.
Okay, it should be up there now. You might have to refresh, but it's like right at the bottom of the chapter 1 stuff. Okay, so similar to the video, Mrs. Gallus wants to use a beverage to test the effect that caffeine can have on heart rate. Here is the initial plan. She measures the initial pulse rate, gives each student some caffeine, gives them Coca-Cola, waits for a specific time, measure final pulse rate, and then compares the final and initial grades. What are some problems with this plan? Idea, Sophie?
How much caffeine is she giving them?
Okay.
How many ounces?
Yep. So consistent. I'll say need.
Yeah, that's what I was thinking too. Like,
Yeah,
why weight
Kelly
and
looked at me
everything.
like I was insane.
I didn't say anything.
Yeah.
I like that. So you guys are kind of thinking of like some other variables that could cause the rate to increase other than just the caffeine. That would be like a confounding like variable. I don't know how to spell caffeine. Okay, here it is. All right. Also, I was like thinking, if they're gonna Coca-Cola, it could be like the sugar that increases their heart rate, or like you said, like other factors. Maybe sugar or other factors.
What about like
Increased pulse rate. Yep, what were you gonna say?
like what were they doing before the initial pulse rate?
Yep, that could also affect it. Yep, all these other factors. Those are like confounding variables. There's another big problem with this like experiment she conducted.
How much time? There's no control group.
There's no control group. Good. Yeah, there's no control group. There's nothing to compare the results to. Nice, Sam.
For you.
The other one I came up with is they obviously like know they're getting the caffeine. They like know they're getting this Coca-Cola, so they could have a little bit of this like placebo effect that they like think it's gonna increase their heart rate.
You can still have a placebo effect even if you receive treatment.
Yeah. So, I mean, that's pretty much what it is. That's what it is. It's like you know you're getting it, so you act differently. Well, I guess it goes in the other way too, that you like think you're getting it. Yeah. So I see what you're saying. I don't know where this. They know they are receiving caffeine. Now, it's not like they can really control their heart rates, but could just kind of be in their head that they feel like hyper. I really struggle with spelling caffeine. I just really think it's annoying.
You should. Write this down. Maybe. Not the last one.
It's memories.
Sorry, I know this is pretty low. Placebo. Okay, good. That was a good list. back to our list. Propose a solution to each problem.
Have like the experimental group like be in the same conditions before the experiment, so they all have like the same or be close to the same initial.
Yep, I like that. Make sure that nobody just came from like by a class or something like that. Have them all come from the same preceding condition so that their heart rates are similar. And we are measuring their initial ones too. Easy fix here would be to make a control group, right? That would give us something to compare our results to. Maybe sugar or other factors increase. I mean, if we're using Coca-Cola, there's really no way to eliminate like the sugar from that, but we could do oh, I know what we could do. Have you guys ever seen like the caffeine free Coca-Cola?
Ooh, here it is.
So we could
So then you could see the effects of the sugar too. In
Yeah.
The control group.
give the and they don't know which one's receiving which one.
Yes.
Oh, bingo. Okay. Good idea. What else? They know. Okay, that takes care of that too. Yeah, obviously we're not gonna be able to get like the same body weighted person, the same like coming from the same whatever they did that morning, but we can try to be as random as possible with the groups. So we'll kind of talk about that then in number 4, when we're gonna design this experiment in a better way. We're gonna help this teacher out to test the effect that caffeine has on heart rate. Okay. Does it say how many students we have? I don't think so. Let's say, I'm just going off with this answer key. Let's say we have 32 students. So, the best way to organize the groups is to just do it randomly. So we're going to use random assignment. So we would number them and use a random number generator to pick the first 16 to be in group 1. And the other 16 in group 2. That's the best way we can form our groups is by random assignments. Okay. So the groups don't know which one's going to get the real Coca-Cola and which one's going to get the caffeine free. Okay, that we're going to keep that blind. So let's just say for group 1, we'll give them treatment number 1, which is caffeine Coca-Cola. Group 2 gets the second treatment. I don't think there's sugar-free. That's just Diet Coke, right? It's sugar-free.
Is this sugar? Is it actually sugar free?
It has aspartame in it, but there's no carbs in it. Yeah. We could do that as a third group too if we wanted to. We could do one with Coca-Cola, one with caffeine-free, one with sugar-free, and measure those different. But for right now, since we're just trying to measure caffeine, we'll just stick with caffeinated and caffeine-free. Are you done, Bree?
Yeah.
Okay, perfect. And then we'll compare those results. Compare change in heart rate. Okay. So basically, we'll take the students, randomly split them into 2 groups. One group, regular Coca-Cola, one caffeine-free. They don't know. Maybe we could add that in blind. That will help at least reduce the placebo effect a little bit. So they're like, oh, I'm getting this caffeine, I'm inactive. Or they don't know, they're blind to it. And then we can compare their heart rates. And that would create a better experiment than what she started with. Okay. So, big ideas from this lesson, I'm not going to have you like rewrite all these definitions. I feel like I kind of have been doing that, but just some like notes because you guys kind of already know a lot of this from AP Psych. Important group or important ideas. We want a control group. Talked about that, control groups. Talked about blinding. Talked about the placebo effect. Those are, I think, are basically our big ideas. The only thing else I put in here was when you're conducting a random assignment. To do that, you do like those 3 steps. Label, random number generator, select. Okay. And our 4 key principles, we just wrote this down too. Of an experiment, comparison, so when I have 2 or more treatments, like the caffeine-free and the regular Coca-Cola. We want random assignment when we're selecting our groups. Okay, we modeled that. We want a control group. We did that. And lastly, we want this to be easy replicated. Which I think you could do with any group of people easily. Okay. So we just have this little check for understanding question. I'm going to give you a minute just to read through that. This is like a geometry assignment. If there's anything mixed in, just set it aside. So basically I just like check, like this is the assignment, so even I just like try to make sure they have this done. Like 43, 44, and 37, and then like a lot of they don't change if they want to reverse any of these ones, these recipes, have to go over. I was just like, have 15 and that okay. But and for some of like the word ones, like these ones, there's not really a lot of work, but there should be like something. Yeah, and if they don't show work, I usually try. Usually, if it's just like 1 or 2, if it's the whole thing, then I give it back to everybody. So just go through and just check the ones that like look like you have questions on one, and I can probably help you through it. Okay.
And that's fine.
Yeah. Okay, so you read about these cows things. Explain why it's important to have a control group that didn't get a mark on their rear.
Oh.
Did you read it?
Yeah.
Oh, okay. So it was like some got marked with like a cross, right? And some got marked with, what was the other one? Eyes on the rear of these cows. So why would we need to have a control group that don't get marked with anything? It gives us something to compare it to, right? Provides baseline data. So we have something to compare it to. It'll show us how many deaths with no treatment. Okay. Suppose the researchers have 1,200 cows. How could we randomly assign the cows to the treatment? Okay, so we want 3 groups here, right? We want some with the eyes on the rear, some with the crosses, and then some without anything at all.
Random number generator.
Yes.
3 groups.
Good. How many people are going to be in each group?
Are there different
400 question mark?
Yes. Yeah, 400. And they're all the same cows.
Oh.
It's all the same cattle. Good question, though. So we'll have to label all the cows. This will be annoying. 1 to 1,200. Use what Sophie said, random number generator, to select. We'll do 3 groups of 400. 400 unique numbers. Okay. And then we'll assign groups treatment, eyes, cross marks. Or no marks. But we do want to have that control group. That's important. Okay. What is the purpose of randomly assigning treatments in this context?
So fair. Well, I
Can we?
You're kind of right. So like each cow has like an equal chance of being a part of each group. So, and this kind of actually goes off of what Austin's asking, like, are these all the same cows? Basically, like, just to make sure, like, we have a mix of, like, all the kind of, like, different sizes of cows or something like that. So it just ensures that, like, we're not grouping them based on other factors. Creates roughly equivalent groups by balancing out variables like cow size is what they have in here. So we'll just put creates roughly equivalent groups. Every cow has an equal chance of being selected. Okay, so create an outline showing a completely randomized design for the experiment. So we'll kind of use like those arrows again. So we have our 1,200 cows. We're going to do random assignment. This one up into 3 groups. Group 1. Group 2. Group 3. We'll assign treatment. So let's say treatment number 1 is the eyes for group 1. Treatment number 2. So those are the cross marks. Treatment number 3, nothing. No marks. And then we'll compare the number of deaths. Okay, so it kind of takes care of those 4 key principles of an experiment. We have comparison between the different treatments. There's 2 more treatments. We did the random assignment with the groups. We have a control group. And this can be easily replicated. Uses enough experimental units to distinguish differences. We have 400 in each group. You can add that in if you want to. You don't have to. 400, 400, 400. Okay, there's a little activity on the good old placebo effect. I'll continue in the notes tomorrow.